When dealing with an 800 amp service feeding a transfer switch and subsequently running 4 sets of 4/0 wires in EMT conduit to a splice cabinet, determining the correct size of the equipment grounding conductor, or EG, for each set within each conduit is crucial for safety and code compliance. The National Electrical Code, or NEC, specifically Section 250.102c, provides guidance on this matter. According to NEC 250.102c, the minimum size of an equipment grounding conductor for a 4/0 AWG circuit is 1/0 AWG. This requirement ensures that the equipment grounding conductor can adequately handle fault currents, providing a low impedance path back to the source and facilitating the operation of overcurrent protective devices. The code reference, NEC 250.102c, elaborates on the sizing of equipment grounding conductors. The equipment grounding conductor should be rated in accordance with Table 250.102c and should not be smaller than the specifications outlined in the code. For alternating current circuits rated 1000 volts, nominal or less, and having a maximum circuit rating of 1000 amps or less, the grounding conductor requirements are detailed. For circuits rated 100 amps or less, the grounding conductor should not be smaller than 8 AWG copper or 6 AWG aluminum. However, in your case with an 800 amp service and 4/0 AWG conductors, the 1/0 AWG equipment grounding conductor is the appropriate size per NEC 250.102c. In addition to proper sizing, there are several other considerations to keep in mind when installing equipment grounding conductors. Firstly, if the equipment grounding conductors are installed in an EMT conduit, it is recommended to use them in conjunction with a single bonding jumper between the EMT and the equipment grounding conductor. This bonding jumper ensures a continuous low impedance path for fault currents, enhancing the effectiveness of the grounding system. Secondly, the equipment grounding conductors should be identified with green insulation or be bare copper. This color coding helps to easily identify the grounding conductors and distinguishes them from other circuit conductors. Finally, the equipment grounding conductor should be properly connected to the transfer switch, the splice cabinet, and each connected panel board. These connections should be made using appropriate listed connectors and should be told to the manufacturer's specifications to ensure a reliable and low impedance connection. To summarize, for an 800 amp service with 4 sets of 4/0 wires in EMT conduit, the minimum size equipment grounding conductor for each set should be 1/0 AWG, as per NEC 250.102c. Also, ensure that the equipment grounding conductors are properly bonded to the EMT conduit, identified with green insulation or bare copper, and properly connected to all relevant equipment. Always consult the latest edition of the National Electrical Code and local amendments for the most up-to-date requirements, and consult with a qualified electrician or electrical engineer for specific applications. The equipment grounding conductor, or EG, plays a vital role in electrical safety by providing a low impedance path for fault currents to return to the source. This low impedance path facilitates the rapid operation of overcurrent protective devices such as circuit breakers or fuses, which interrupt the flow of current and prevent electrical shock hazards or equipment damage. Proper sizing and installation of the equipment grounding conductor are crucial to ensure its effectiveness in clearing faults and protecting personnel and equipment. The size of the equipment grounding conductor is determined by the size of the ungrounded conductors in the circuit. NEC Table 250.122 provides guidance on the minimum size of equipment grounding conductors based on the rating of the overcurrent protective device in the circuit. In general, as the size of the ungrounded conductors increases, the size of the equipment grounding conductor also increases. However, there are some exceptions and specific requirements that should be carefully considered. For example, if the ungrounded conductors are paralleled, the equipment grounding conductor should also be paralleled and sized accordingly. Additionally, if the equipment grounding conductor is installed in a metallic raceway such as the EMT conduit, the raceway itself can serve as the equipment grounding conductor under certain conditions. However, the raceway must be properly installed and meet specific requirements outlined in the NEC. It is important to note that the equipment grounding conductor is not the same as the grounding electrode conductor. The grounding electrode conductor connects the electrical system to a grounding electrode, such as a ground rod or a metallic water pipe, to establish a connection to the earth. The equipment grounding conductor, on the other hand, connects the non-current carrying metal parts of equipment to the system grounded conductor and the grounding electrode conductor. The purpose of the equipment grounding conductor is to provide a low impedance path for fault currents, while the purpose of the grounding electrode conductor is to stabilize the system voltage with respect to ground. In addition to proper sizing, the equipment grounding conductor must also be properly installed. The equipment grounding conductor should be run with the circuit conductors in the same raceway or cable. This ensures that the impedance of the grounding path is minimized. The equipment grounding conductor should also be securely connected to all metal enclosures, boxes, and equipment that are likely to become energized during a fault. These connections should be made using listed connectors and should be torqued to the manufacturer's specifications. It is also important to ensure that the equipment grounding conductor is continuous and unbroken throughout its length. Splices in equipment grounding conductors are generally prohibited, except under certain conditions. If a splice is necessary, it should be made using a listed splicing method that maintains the integrity of the grounding path. When working with electrical systems, it is always important to follow safe work practices. Always energize the circuit before working on it. Use appropriate personal protective equipment, such as gloves and safety glasses. And never work on electrical systems if you are not qualified to do so. The NEC is a comprehensive document that provides detailed requirements for electrical installations. It is important to consult the NEC and any local amendments to ensure that your electrical work is safe and code compliant. If you have any questions about electrical safety or code compliance, consult with a qualified electrician or electrical engineer. Now, let's consider a few more specific details relevant to your situation. First, let's clarify the term service in the context of electrical systems. The service is the electrical supply from the utility company to the building or structure. It includes the service conductors, the service equipment, and the grounding electrode system. The service equipment typically consists of a main disconnect switch, a circuit breaker, which allows the entire electrical system to be de-energized for maintenance or in case of an emergency. In your case, you mentioned an 800 amp service. This means that the service is capable of delivering up to 800 amps of current to the building or structure. The size of the service is determined by the electrical load requirements of the building or structure. The transfer switch is a device that allows you to switch between two different power sources. In your case, the transfer switch is likely used to switch between the utility power and a backup generator. When the utility power fails, the transfer switch automatically or manually switches to the backup generator to provide power to the building or structure. The transfer switch should be properly sized to handle the electrical load of the building or structure. The splice cabinet is a junction box where the conductors from the transfer switch are spliced to the conductors that feed the distribution panels in the building or structure. The splice cabinet should be sized to accommodate all of the conductors and splices. It should also be properly grounded and bonded to ensure electrical safety. You mentioned that you have 4 sets of 4/0 wires in EMT conduit running from the transfer switch to the splice cabinet. The reason for using multiple sets of conductors is to increase the ampacity of the circuit. The ampacity of a conductor is the maximum amount of current that it can safely carry without overheating. The ampacity of a 4/0 AWG copper conductor is typically around 230 amps. By using 4 sets of 4/0 wires, you can increase the total ampacity of the circuit to 920 amps. However, it is important to note that the ampacity of the circuit is limited by the lowest rated component in the circuit. In your case, the 800 amp service limits the maximum current that can be delivered to the building or structure. EMT conduit, or electrical metallic tubing, is a type of metal raceway that is commonly used to protect electrical conductors. EMT conduit is lightweight, easy to install, and provides good mechanical protection for the conductors. EMT conduit is typically connected using compression fittings or set screw fittings. It is important to properly tighten the fittings to ensure a good electrical connection. When running conductors in EMT conduit, it is important to follow the fill requirements of the NEC. The fill requirements specify the maximum number of conductors that can be installed in a particular size of conduit. The fill requirements are based on the size of the conductors and the size of the conduit. The purpose of the fill requirements is to prevent overheating of the conductors. Now let's address some potential misunderstandings. Some people may mistakenly believe that the equipment grounding conductor only needs to be sized to handle the available fault current. While it is true that the equipment grounding conductor must be able to safely carry the available fault current, it must also meet the minimum size requirements specified in the NEC. The minimum size requirements are based on the size of the grounded conductors in the circuit and are intended to ensure that the equipment grounding conductor has sufficient capacity to clear a fault quickly and effectively. Others might assume that if the metal conduit is properly grounded, a separate equipment grounding conductor is not needed. While it is true that metal conduit can serve as an equipment grounding conductor under certain conditions, it is not always the case. The NEC specifies the conditions under which metal conduit can be used as an equipment grounding conductor. In general, the conduit must be properly installed, and the fittings must be listed for grounding. It is always best practice to install a separate equipment grounding conductor in addition to the metal conduit, especially in critical applications or where the integrity of the conduit system may be compromised. Consider also that some might think that the equipment grounding conductor only needs to be connected to the metal enclosures of equipment. While it is important to connect the equipment grounding conductor to the metal enclosures of equipment, it is also important to connect it to the system grounded conductor and the grounding electrode conductor. This creates a complete grounding path that helps to stabilize the system voltage and provide a low impedance path for fault currents. Then there's the mistaken belief that the equipment grounding conductor is only necessary for safety. While it is true that the equipment grounding conductor plays a crucial role in electrical safety, it also serves other important functions. The equipment grounding conductor helps to reduce electrical noise and interference, which can improve the performance of sensitive electronic equipment. It also helps to prevent the buildup of static electricity, which can damage electronic components. Finally, there's the misconception that all grounding conductors are the same. There are different types of grounding conductors, each with its own specific purpose. The equipment grounding conductor connects the non-current carrying metal parts of equipment to the system grounded conductor and the grounding electrode conductor. The grounding electrode conductor connects the electrical system to a grounding electrode, such as a ground rod or a metallic water pipe. It is important to use the correct type of grounding conductor for each application. In summary, always refer to the latest version of the NEC and consult with qualified professionals for any electrical work to ensure safety and compliance.